Hi everyone, I'm Rose Hoffman and I have problem number 20 from section 4.1. So the directions for this problem ask you to find the Laplace transformation of the given function, and I went ahead and wrote down the Laplace equation. You can find it on page 267 in your textbook. So as I said, starting off with that equation, I plugged in our function of t, which would give us the integral from 0 to infinity, e to the negative s times t, times our function of t, which is te to the t. I went ahead and simplified this to get the integral from 0 to infinity of te to the negative st plus t. And then simplifying even further, you'll see why I am doing this when we start integrating this function. So it'll be te, and then I went ahead and factored out a negative t. So it'll be e to the negative t times s minus 1. So now that I have this, in the directions it asked you also to use integration by parts if necessary. So this is one of the cases where you do need to use integration by parts. So I went ahead and made my ut, and then therefore my du would be 1. My dv, I made e to the negative t times s minus 1. And integrating that, this is where that one simplifying step comes in here. It's going to be e to the negative t times s minus 1. So you have to divide by the derivative, and dividing by the derivative of that is going to be s minus 1, all that's times negative 1. So that is my v term there. And to do integration by parts using the parts that I just found above, you use uv minus the integral of v du. So that uv, it's going to be t times my v, which is negative e to the negative t times s minus 1, all over s minus 1, and then minus the integral of v again, which is negative e to the negative t times s minus 1, all over s minus 1, and then this entire term is times du, which is just 1. I'm not going to put that in, and again that's dt in terms of t. So I'm going to switch over to a new slide here and continue simplifying our equation here. Alright, and as I was saying, I'm just going to simplify both terms here. So this left-sided term is going to simplify to negative t times e to the negative t times s minus 1 all over s minus 1. And then integrating that right-sided term, you're going to get minus, and that's going to simplify or integrate to e to the negative t times s minus 1, and then again dividing by that derivative yet again is going to be s minus 1 squared, and it becomes positive because you are dividing by a negative or another negative 1. And then this entire expression, don't forget your limits of integration on that. And okay, so that's what we get after we simplify and integrate. And now I'm going to actually rewrite this a little bit more, and you'll see why. So this left-sided term is going to be negative t over e to, this is going to be a positive t now, so t times s minus 1 times s minus 1. And this one over here is going to be minus 1 over, bringing that again down to the denominator, is going to be e to the positive t times s minus 1 times s minus 1 squared. Alright, and so our next order of business here is to plug in our limits of integration from 0 to infinity. So beginning with infinity, plugging infinity in for t, you're going to get negative infinity over e to the infinity, and then times the rest, everything over here. And it doesn't really matter what that is at this point. You're going to get negative infinity over infinity, which you can't have when you are plugging back in your limits. So this is one of the cases where you have to use L'Hopital's rule. So using L'Hopital's rule, you're going to take the derivative of both the top and the bottom, So taking that negative t over e to the t times s minus 1 all over s, or times s minus 1, and I'm going to take the derivative of this, so that is going to be, so dt, d over dt, take the derivative, and that's going to equal negative 1 over e to the t. It doesn't really matter what the rest of this is because I'm just plugging in infinity for this term. So plugging in infinity for t, you're going to get negative 1, again, e to the infinity times some number, whatever it is, which is going to simplify to negative 1 or negative 1 over infinity. And whenever you have negative 1 over a number that gets increasingly larger, it's just going to come to 0. So that is plugging in infinity for that left-sided term. Now I'm going to do it on the right side, so this term here. And so we're going to plug in infinity for t, and you will get negative 1 over e, again, to the infinity. Doesn't really matter what the rest of the stuff is here. So it's just negative 1 over infinity, which we said just above there is 0. So after plugging in infinity, it's just going to be 0 minus 0. And now we have to subtract the limits that we get, or the numbers that we get when we plug in 0, our other limit. So I'm going to switch over again to a new slide here and continue with this problem. Now continuing on, as I was saying, we just finished plugging in our limit of infinity, so now it's time to plug in 0 for all of our t's. So doing that, it's going to be negative 0 over e to the 0 times the rest of this. Again, it doesn't really matter what it is, so it's going to be negative 0 over 1, which is just going to equal 0. So that's the left-hand side, and plugging in 0 for the right-hand side, you get negative 1 over e to the 0 times the s minus 1 times s minus 2, or s minus 1 squared. Again, this doesn't really matter. This is going to be equals negative 1 over e to the 0 times s minus 1 squared, which this is just 1, and that will simplify to negative 1 over s minus 2, or s minus 1 squared. So at this point, we had the 0 minus 0 for our limit of infinity, minus, so subtracting our limits, the limit for 0, the left-hand side we got 0 minus, and then our 1 over s minus 1 squared. Then I distributed this negative sign here, and you'll just be left with 1 over s minus 1 squared. So this is our answer for our Laplace transformation. So f of s is equal to 1 over s minus 1 squared. Alright, so that is our answer here. I hope that made sense and cleared up any questions you might have had. So thank you for watching.